security. My name is Visweshanand Krishnan. I'm the Senior Director of Product Management here at Aruba. So let's get into it. So over the course of the next hour, I'll give you an introduction to what we mean by Zero Trust and talk about the two different products that comprise the solution for the most part at Aruba, along with several other products as well and third-party products as well. We'll finish off with a real demo so that we can make this all real for you. And so let's get into a few slides to set the stage and the context for this discussion. So Aruba just launched its Edge Services platform as part of ATM. And here are the sort of three main pillars of this platform. And if you heard Kirti, our CEO, speak at the keynote address on day one, he explained it really well. But if you missed that, here's a quick recap. The first pillar, of course, is AI Ops. We really want to make consuming networking and security as simple as possible for our end users. So in order to do that, we collect a lot of rich telemetry from these devices. We are able to prevent most problems before they happen by alerting our customers on what to look for and avoid. And also, if should something go wrong, we are able to root cause and give a lot of search support in terms of investigating some of these problems. So that's really AI Ops. The second pillar, of course, is unifying all of the Aruba infrastructure to make it very seamless and consistent for an end user experience. So a few examples of that: we have consolidated on a single operating system across our switches. So whether you're in the campus or the branch or in the data center, you use a single operating system across all of these different lines of switching. An example on our wireless infrastructure is, irrespective of whether you're using a controller-based architecture or something we refer to as our instant-on products, you can now manage and configure all of these access points in a very consistent way through the cloud without having to deal with the differences between controllers and controllerless. A third great example of unified infrastructure is how we deal with access to the WAN and securing that access. Whether you're using MPLS connectivity or simply broadband, Aruba's SD-WAN products give you that consistent, uniform experience to both configure, scale, and install and deploy a high-performance infrastructure. The last piece, of course, which we're going to talk about today is Zero Trust. Right from the very first product that Aruba built several years ago, which was Secure Wireless, we now have a great story to tell around dynamic segmentation that brings the power of Aruba over many, many years, all the innovations that we have done on the Policy Manager, plus some more recent advances that we have launched in device visibility to really tie all the pieces together, a rich overlay of security for dynamic segmentation across all of Aruba infrastructure. So if you look at the life cycle of how Zero Trust works at Aruba, here's a quick picture of the various stages. Now, before I get into this, I just want to step back a little bit and define what Zero Trust means for us. Now, like most other terms in the industry today, whether it's AI or cloud, everybody has a slightly different take, a slightly different meaning. But if you get down to it, what Zero Trust really means is, independent of the person, the location, where they're accessing it from, the time of day, what applications they're trying to access, so on and so forth, we start off the process assuming Zero Trust, meaning we don't trust the user, we don't trust the device, we don't trust the ability to access those assets. And then we establish that access based on a bunch of criteria. And if you go back to some of the work that Google published a while back ago around Beyond Corp, it was really trying to use applications to do that encryption and access control. However, we don't think the world is quite ready to do that across the board for all kinds of apps, for all kinds of markets and customers. And so we are dipping down one level and saying, let's start with the network and let the network do most of this for you while we wait for several few years for all the apps to catch up. So we start with Zero Trust at the network layer, starting with visibility. You can't secure what you cannot see, right? So we start with discovering devices on your network, profiling them, establishing a clear personality for these devices, because you really want to tell the difference between a Windows operating system running in a security camera versus Windows running in a thermostat, right? So you really want to know the true nature of these devices. And once you establish that, you want to authenticate both those devices and the users, okay, for access to the network and to the applications they are trying to connect to, and grant this authorization based on role-based access control. And once people and devices are on the network, you want to continuously monitor that activity so that you can step up or step down the authentication, and continuously monitor to decide if you want to force a reauth, if you will, and do this throughout the life that the device and the person are on the network. And should you find something that is not secure or suspicious or malicious, you would like to now enforce rules, other kinds of enforcement techniques, both on Aruba products as well as third-party products, to curtail that access. And this cycle continues. This is what we refer to as zero trust. And given the onslaught of IoT devices in our environments today, things that are managed, unmanaged, guests, corporate users, and so on and so forth, we really think that this kind of dynamic segmentation without having to configure these kinds of policies on every node in the access is something that really simplifies the life of the end user, makes it really easy to consume the services, and really makes for a secure environment. So if there are any questions on this, we can talk about it now. Otherwise, we'll get into the details of the products that implement zero trust at Aruba. Okay, so representing that same workflow in the context of the specific products that we use. So on the left side, we are starting with ClearPass Device Insight. Launched less than a year ago in trial mode, and it has gone GA now this year in January with good success in the early POCs and an adoption. This product works as an adjunct to the ClearPass Policy Manager, much like a front end. It can be used standalone, but its real power comes when you combine it with the Policy Manager. It automatically, using both traditional static attributes and rules, in addition, also using things like machine learning, it profiles your devices, establishes a personality for those devices, and communicates that, all of that rich detail with metadata and context to the Policy Manager, something that we have never done in the past till CPDI, as we refer to it, came on the scene. Of course, now with the Policy Manager, you can write policies both to authenticate those users and devices, and then assign them to roles based on the same policies, and then use those roles now to grant access to those, to decide the access authorization to those devices and users. And of course, while we, after having granted that access, we monitor their behavior on the network, both ourselves by using Aruba products like IPS, PEF, and also a large ecosystem of more than 150 different security partners to constantly acquire and feed that metadata back into the Policy Manager so that they can now be continuously used by our policies in coming up with re-authentication or enforcement within Aruba or rest of the network. And so this cycle, this virtuous cycle, continues from there on. So I'm going to quickly dive into the details behind the products that we talked about so far. I'll start first with advanced visibility with ClearPass Device Insight. One of the first visibility platforms to be provided as a SaaS service. If you think about it, most of these solutions were based on appliances that had to be installed inside silos of enterprises. This solution really supports a new architecture of distributed sensors that all feed into a common analyzer that is located in the cloud, and visibility being delivered as a SaaS service. These individual sensors, of course, are highly capable, use deep packet inspection to extract flow attributes from these devices. So gone are the days where you can rely solely on static attributes like MAC addresses and DHCP options. Because as you know, with some of the newer smartphones and other devices, these MAC addresses are now randomized, so it's very hard to establish a one-to-one relationship between MAC address and a device type. You really have to look deeper into the behavior of the device. And if you still want to rely just on static attributes, you have to look for more static attributes. So the deep packet inspection allows us to do that. It extracts things like the TCP fingerprint, which are unique to devices. Once we extract all of this rich information, it's sent to the cloud where we apply both rules and machine learning techniques to classify these devices. We let end users assign their own classifications, which through crowdsourcing, we can now share across all tenants, so it benefits everyone. And now with the 2.0 release that came out just last month, we have added a very rich layer of security features on top of basic device classification. So now we are also now able to analyze vulnerabilities and the device posture of the software running in these devices, compute a risk score, and also feed that security risk score into ClearPass Policy Manager. So this is one more item to add in terms of policy making, something that takes into account the security posture of these devices. Of course, we have been at the integration for a while now. So starting roughly middle of last year, when we first integrated with ClearPass Policy Manager, this integration is now very rich. It doesn't suffer from any kind of API or scale limitations that you might have when you're trying to connect third-party visibility solutions using APIs. This is a native integration within Aruba, so it really performs extremely well. In terms
can you talk about a couple of the profiling methodologies? I think you mentioned maybe DHCP fingerprinting. I'm sure there's some maybe port scanning technologies, or are we mirroring traffic here? Can you just hit on a little bit of that?
Sure. I think I have a slide that's coming up that dives into a little bit more detail, but I can start over here. So in terms of the collection technologies, the collector, which is an appliance available as in a hardware form factor, or something you could deploy as a virtual appliance. This collector collects span traffic. It can collect span traffic passively. It can also support DHCP helper options to receive DHCP traffic and extract device information from that. In addition to that, it's also a location from where you can launch active scanning services, be that WMI or other such techniques, to go query the devices to gather more information. So those are techniques supported by the appliance itself. But as the slide shows, we are also now collecting the same kind of rich telemetry from Aruba infrastructure directly without the need for an explicit dedicated collector. And this really is one of our innovations in the recent months. It's something that our branch customers, our distributed deployment customers have really asked us for. So we have had oil companies asking us to support this in their branch offices, on rigs, all kinds of distributed infrastructure where it's really hard to maintain, manage, and administer for space reasons, for cost reasons, dedicated collectors. So starting with Aruba Central 252, which is coming out in the very near term, either this month or next month, what we'll have is support for our instant on access points, where just using the MAC address coming from these access points, we can now give you very good classification, both in terms of accuracy and coverage. And then later in the year, in our 253 release, we'll have support for our security gateways. So there, sheerly by virtue of observing the traffic that's traversing these gateways, we can extract MAC addresses, DHCP options, user agent strings, application IDs, domain names that have been accessed, TCP fingerprints, so on and on and on. And all of this is really good grist to this mill of classification. So what difference does this rich classification really make? So as a quick example, we were pleasantly surprised when we refurbished our the 6th floor in our building and put iPads in front of conference rooms, at first, using our rules-based approach, we didn't really classify them as iPads. But once we introduced machine learning to the picture, an iPad that a guest brings with them as they walk into a conference room versus iPads that are hoisted in front of conference rooms as booking devices, we could now tell the difference. And the 6th floor iPads, even though they were now based on new types of user agent strings, hence the rules failed, now started getting classified and clustered along with all other conference room iPads in the rest of the building. So another sort of very real life, unexpected example of how machine learning really steps in and solves those problems that rules have unable to solve in the past. Our philosophy around rules is the following. They're hard to maintain, they're brittle, they have to be maintained by human beings who are often lazy or greedy or fearful and so on and so forth. So they're very hard to be effective over the long term. However, we do think rules are important when you first start on your machine learning journey because they really help you train and bootstrap the system for some of these machine learning techniques. A great example of another such service sitting in your living room is the Alexa device. And so when Amazon started training Alexa devices for voice commands, they really started with simple rules, like who's the president of your country? And then when it got to more complex things like, remind me to feed my baby before 2 p.m. today, those things now required machine learning. So I'm just providing this example to sort of showcase the difference where rules are required, where they're important, and where machine learning really steps in. And a good segue to this slide is to talk about specific techniques in machine learning that we are using now. So on the left side, you'll see simple lookup tables, manually curated rules, and we share a lot of that with the policy manager. Historically, that's where the profiling was done. But starting around December of last year, we introduced the MAC range classifier. And what this does is, by virtue of seeing the MAC address across all devices in our current tenants, we can apply a Gaussian process to map and model the distribution of these MAC ranges so that when a new device shows up with a MAC address that we have never seen before, we can easily look up one of these ranges and tell you what type of device it is. So it's really a machine learning model that's based on observing real MAC addresses over time. The second technique we use is LDA clustering classification, which allows you to cluster devices that behave similarly and then extract classification from them. And finally, an example of how we work around the MAC randomization problem, where the MAC address is no longer reliable, but we can still extract other static attributes that cannot be obfuscated, things like the TCP fingerprint, so that we can now start classifying on the raw TCP fingerprint, things like the window length, the don't fragment bit, the options in TCP, the SYNAC flags and the combinations used therein, and so on and so forth. So those are sort of three models that are currently in the product. There are more coming in our roadmap. We are looking at automatically extracting rules so that you don't have the need for a human in the loop to bless them before you can put in production. And also something we're calling a ranker, which is now a way to compare multiple methods at runtime and pick a method that's most suited to the type of device that is being classified instead of following a strict order of classification as shown in this picture here.
I have a question around some of the MAC range, maybe overlay technology, or because I know we've hit this just as a technology, not specific to any products, but in different environments where in site a GE owned MAC address could be a turbine system, and over here it could be a refrigerator. Is that getting overlaid with any of the other data that you have from a profiling perspective to put context around that, or is it just one piece fed into it?
Great question, and I think I have a slide that I can use to answer that. I think it's my very next slide. So as you can see here, I have several devices that are both Windows and Apple devices and Chrome OS as well, all on the slide. And so now how do you tell the difference between an iPad and an iOS device and an iPhone, all made by the same manufacturer, much like the example you asked around GE. And the way we do this is we bootstrap the learning system with the results of our rule-based approach. So the rules tell you exactly if it's an iPad or iOS or an iPhone. However, the problem with rules is if you write a rule that works 99% of the time, there is still a 1% of the time that it misfires and leads to a misclassification because perhaps you didn't see all of the attributes at that time, right? And so that is shown by some of the noisy firings you see in the bottom rows of the slide. But now, if you were to sort of squint your eyes a little bit and look at the top two rows, it's very obvious now that you can see a range of MAC addresses clearly belonging to just, say, an Apple iPad. And so that's how we tune the model and learn MAC ranges, so that now, if you see a MAC address in that range, you know for sure it's an iPad, and you can now clear up all this other noise that might suggest, based on a rule, that perhaps it's a Windows system or a Chrome OS and things like that. So to recap, the answer is this model is trained from our rule-based systems. So it's not just based on the MAC address. We learn the MAC address to be a certain device type based on a number of other attributes. And so you can think of this as a form of transfer learning. We learned using a bunch of different attributes, boiled it down to a MAC address, and then built a model based purely on the MAC address range.
Would it be fair to assume, and we're kind of having a chat about this, would it be fair to assume, because there's definitely, NIC manufacturers that are kind of generic, and then of course, different products would snap those in. So I'm assuming based on this technology, you guys would see that the lack of pattern, for example,
yes,
if you had a MAC range. Okay, cool.
Absolutely, because our rules would never lump them all together. And so the training of this model would not get misguided by that. So even though they may all map to the same MAC vendor, and we have seen a bunch of that, right? So a Zebra MAC vendor is used both in a Alaris infusion pump, which is a medical device. It's also used by a Motorola access point. And so now it's very easy to say it's one or the other purely based on the MAC address. But if you also now look under the hood and look at the specific TCP port and protocol it's using, you can train based on the rules that it's really a different type of device, and thereby assign that MAC address to a different category of device, and then train this MAC range based on that. So on to our next technique, which is how you automatically cluster devices without knowing anything about them. And we were inspired by topic modeling techniques used in document classification. So for example, if you're browsing on a website like medium.com, and if you've ever wondered how it automatically serves you articles on your topic of choice, be it health or sports or technology, without you having to tell it anything, the technique it's really using under the hood is latent Dirichlet allocation. So if you skim through this article in front of you, you'll see that it uses words like genes and computers and living and genomes, and you might surmise that this is maybe some article on biology or computation or living. And a machine does pretty much the same thing. It picks up on these words, and by the occurrence of these words together, it assigns them to different topics. Now, of course, it does not know that this is a biology or computer, but it sort of gives it a nameless topic heading, but is now able to infer topics hidden in this document. And that's the reason it's called latent, because these topics are latent, they're not obvious. But what the machine can then do after that is look across all the different documents in a corpus, and looking at the distribution of topics, it can say topics with more of blue go together, topics with more of red go together, and then be able to say these form one cluster and those form the other. We do something quite like this in our device classification, where the behavior, which is the user agent strings, the applications used, the domains accessed, we treat them like words in a vocabulary of a language. We infer the topics hidden, and then we cluster them together based on this topic distribution. But as I said, this still doesn't tell you what type of device it is. It just tells you these are similar types of devices. Then what we do is we do this across both the known devices and the unknown devices. And by association, we can tell that some of these unknown devices are really of a particular type because of the percentage of classified devices that end up in that same cluster. And Mark will show you a really live demo of this right after I finish presenting these slides. And so that will really drive this point home. We touched upon this earlier. If you have a brand new device that shows up at a tenant, maybe the latest smart bulb, and Aruba has not seen it yet, we don't know what it is, but a tenant can write a rule describing that device. As soon as we get that, we can curate it, promote that user rule to a system rule. It's now available to all our tenants worldwide, and everybody can mutually benefit by this kind of sharing. And so we have this crowdsourcing implemented in the cloud so that it's not trapped in enterprise silos where it's harder to now share this information. So that summarizes the highlights of our device visibility platform. And so I'll shift gears now to talk about how this visibility platform seamlessly integrates with our policy manager. So I show this by a bidirectional arrow on the left side. Device Insight sends all of this rich metadata to the policy manager. In addition, it can also do very simple filtering and tagging, which is, I can run a query to say, show me all the devices in this building from this lab managed by Bob, and simply add a tag saying Bob's IoT devices. Now that goes as an attribute to the policy manager. So now you can write a policy around Bob's IoT devices. And so this ease of use of easily defining policies is something that I think the rest of the products in the market really don't have. Looking at devices, quickly filtering them, assigning a tag, showing up in the policy manager, writing a policy, and performing some actions literally takes less than a minute going through this entire workflow. And so I think we'll have a chance to demo some of this for you also today. On the right side, we're showing similar types of integration with more than 150 partners in the ecosystem. So whether that's a security product in the network, on an endpoint, or in the cloud, they can all send us that rich metadata to be used in our policies. And in return, we can send some of our enforcement back to these locations as an example, by installing a new firewall rule or a new signature in an endpoint device and such. So this really makes for that continuous monitoring piece of the zero trust strategy that we have. Of course, the policy manager is very tightly integrated with Aruba infrastructure on the edge, such as our access points and switches. So we don't have to go around configuring VLANs, other types of parameters on these endpoints. All the policies reside in a central location, and these user-based roles can now be downloaded onto these access points when somebody is trying to connect and apply these policies at the time of connection. Did a bunch of talking. I think now's the time to see some of this in action. So I'll pass the baton over to Mark, who's waiting to show you some of these features.
Could I ask a quick question?
Yes,
we were
please.
kind of discussing it in the background here. And you don't need to go into depth, but like, what about Mac proofing? I'm sure I just got a pretty good understanding of it here from JJ. But could you let other people know in case some people are thinking about the same thing?
Sure. So Mac spoofing is really devices pretending to be somebody else, and so misguiding the security products into thinking that they are somebody else. So if you really want to pose as a secure device, you could, in a malicious way, send out a different MAC address so that somebody misclassifies you now, right? And grants you perhaps access that you should not be given. So clearly there are various types of authentication techniques. There are some based purely on MAC. Those are supported by us. Of course, they lie at the lower end of the quality of authentication, if you will. We do all the way from simple MAC-based authentication all the way to 802.1x, which is very sophisticated. So we take into account not just, say, a device type, but also all the way to how to validate the credentials of that user who's coming from that device. So in terms of authentication, I think we support the complete gamut. In terms of identifying that device in classification, of course, there is a risk of MAC spoofing, and that is why we don't rely on just one technique. And that also goes to why I talked about the ranker, which is we look across a multitude of different classifying methods, and we kind of pick the best one or the majority one looking across them, because many a times they may not all report the same classification. So we are able to really pinpoint exact classification by not relying solely on one type of classification.
Let me add a nuance to that. So one capability we've had in ClearPass for some time, and that it is enhanced with Device Insight, is that if some device drastically changes its classification, let's say something changes from being a Linux to being I don't know, Windows, or changes from being Linux to being a light bulb, the system can tag it as conflict, and of course you can use that in your policy. You can definitely say, hey, if there's a conflict in the classification, shut this down. So even if you're doing a MAC authentication, you can leverage all those profiling mechanisms and all those machine learning mechanisms to ensure that you're not spoofed, and that someone doesn't get into a network by cloning someone else's MAC address.
Okay, maybe taking that a step further. What about when a device that is and should be authenticated to the network changes its capabilities, right? New features are added due to a software upgrade or something along those lines. Suddenly it's listening on a new port or talking on to a new set of servers. How does that float up, and how is that something that becomes immediate and obvious to your people who are responsible for this before tickets and complaints start coming in, where suddenly their iPhone is broken because it's no longer syncing to iCloud, or whatever that might look like, right? How does that change kind of float up, maybe in the dashboard or through alerting or whatever, to say, okay, this device classification suddenly has new requirements?
Yeah, so even if the classification doesn't change, as in your example, right, and it just changed behavior ever so slightly in a nuanced way, maybe it suddenly reached out to an external destination when it never did in the past. This really goes back to that very flexible way to filter and tag. So I could always create a tag to say, here are the devices that communicate externally. And so now this device that suddenly started displaying this behavior would immediately inherit a new tag, which feeds into the policy. So the policy could always be written taking into account these different types of behaviors, not knowing what will show up, right? And so that is now immediately fed into a tag. And as I said, we have support for, or it's coming in the very near future, for tag-based change of authorization. So we will very quickly require this to be re-authenticated, at which point now we can re-examine everything to do with how to best apply the policy and grant access and authorization for this new personality of this device, even though the ground classification of device type didn't change, but the security posture changed, and so now that can be taken into account.
Awesome. Okay, good afternoon, guys. My name is Mark Ibanez. I am a technical marketing engineer. I work as part of the security product team with Viswesh. And what I'm showing you here essentially is a map guide of what I'm going to show you during this demo. So I have 5 steps here. The first 3 steps here are really about advanced visibility and what we can do on ClearPass Device Insight. So right off the bat, we can't secure what we can't see. So what do we actually see on Device Insight? I'm going to show you that first. The second step is I'll show you how we actually implement machine learning to help classify devices, what Viswesh talked about earlier. And then the third step is how do we actually measure a security risk for the devices that we do see, and what can we do about that? Later on in the demo, I'll show you how we can actually scale to branch locations. In particular, for existing Aruba customers that are deploying branch gateways, you can see that we can collect telemetry information directly from the branch gateway and use that for classification and profiling on Device Insight. And the last step is really how do we close the loop? So how do we take all the information that we get on Device Insight, integrate that with Policy Manager, and be able to implement secure access policies on devices of interest. Okay, so let's go ahead and dig in. I'm showing you here essentially is the UI dashboard for ClearPass Device Insight. This is basically see the total number of devices we see here is around 4K. Our customers that have deployed this product, normally this is an eye-popping number, meaning it's 100K, 200K and above. And they're kind of amazed about how many devices they actually see on their network. So over here, you'll see a cross-section of what devices we do see. In this particular environment, you'll see a cross-section of user-based devices, such as Apple iPhones, Windows devices, Androids, and so forth. You see network-based devices like switches, and you'll see several IoT devices as well. For example, Polycom phones, video systems, and medical devices. And I want to hone in on the medical devices in particular to show you what we can see in particular in this case. So if I click on that particular tile, I see there are 25 devices under this category, and I can dig in on one of them in particular. And this actually shows you the profile information that we're able to collect on this particular device. So many IoT devices kind of share like a underlying common technology stack. In this case, it's an IBM chipset vendor, right? So how do we determine that this is actually a medical device that's developed by IBM? So if you look down here, you'll see that, so this is classified by internal system rule. It utilized the DHCP options, which are the static attributes. But what we show here down here is more interesting, right? So what we can collect on our sensor devices, what Vishwesh talked about, we run deep packet inspection. We collect all these flow attributes or behavioral attributes, we like to say. So we can understand what applications are running on this device, what protocols are running, and in particular, what destinations they're connecting to. You'll see like domain names here that are of interest. And the last part here is what ports that are open on this particular device. So if we actually wanted to create a policy for these specific devices, the one example I show here is the concept of tags. So we have a mechanism, and this is what Vishwesh talked about earlier. If we want to, let's say we want to create a least access policy on this particular device. So this is part of our zero trust framework. We only want this nurse call system to be able to communicate, for example, to the St. John Health system. And I created that tag based on this destination connections, right? They're supposed to communicate to St. John's Health based on this domain. And so now I've created a tag based on that specific destination. So now this tag now will follow this particular device and any other device that comes up in the network that communicates with that's supposed to communicate with that specific destination will inherit this tag. And you'll see that this tag, we can close the loop with ClearPass Policy Manager, utilize this tag to implement the least access policy. Any questions so far? Feel free to interrupt me with any questions during the demo. So I just wanted to show you kind of a quick look at what type of profiling information we have here for this sample device. And I'm going to go through machine learning next. But before I do that, do you have any questions on this part?
Mark, I do.
Okay. Yep, go for it.
Shocker, I know. You talked earlier, sorry, someone spoke earlier about some risk scores, and you just mentioned some behavioral attributes, deep packet inspection. I'm kind of wondering. I haven't seen introspect anywhere, so I'm kind of wondering if is that technology rolled into this platform now? Are we getting that benefit?
Right. So introspect, I'll show you the concept of risk score. So we've actually applied some capabilities of introspect. It's not really one-to-one. It's a little bit different the way we implemented it on Device Insight. But the concept of how we measure security risks and analyzing a risk score, I'll go through that as part of the demo, and you'll see what kind of things we can do there. But introspect is yeah, go ahead, Vishwesh.
Sorry, I just wanted to chime in, Mark. Sorry to jump in.
No worries. Yeah.
I just wanted to point out also that you are spot on in observing that similar capabilities. We are pivoting to a lot of our security analytics capabilities to the cloud. And as part of that journey, you are right that CPDI is the vehicle to do that. Introspect being an on-premise product, we are taking some of those things into this cloud offering, because based on our experience with Introspect, a lot of the feedback was we would like to consume this as a SaaS service. So of course, it's starting at a slightly different place with a slightly different set of priorities to begin with. But eventually, if you look under the hood, it has pretty much the exact same architecture, on-premise distributed collectors, all feeding into a single analyzer. So very much the exact same architecture. So yes.
Yeah. Oh, great. And I'm really glad to see that, because I remember when this was kind of announced a few years ago, and the question was, I think it was managed by different teams or different product managers. And so it was, this group wants you to put a bunch of collectors, span and tap ports for this product. And then this group wants you to do it over here for this product. And why can't we make one big happy family with this? So it's really cool to see this evolution.
Yep. Okay, so I'm going to go to the step 2 of the demo, which is how do we use ML to help classify devices? So I'll go back. So what I showed you initially was the set of classified devices here on this dashboard. You'll notice here, this number here, 155, what we call generic devices. And generic devices are essentially devices that are unknown to us, that we haven't been able to longer. Okay. You'll see the ML clustering in action. So we have that latent Dirichlet allocation that Vishwesh talked about. That helps us cluster devices based on common features or common attributes within that cluster of devices. Let me kind of pick a sample cluster here. So let me look at this cluster here. It has 31 devices that are generic, that we're not able to classify. And what we did with the LDA algorithm is we grouped these 31 generic devices with 988 similar classified devices. So these are devices that have already been classified, but they've been clustered with these 31 generic devices due to certain commonalities between these devices. And these are the notable commonalities that we present here. In this case, the commonalities are related to all DHCP options in this particular cluster. And so that's how we actually form the cluster, based on that LDA algorithm. Now, we can make recommendations based on the distribution of those classified devices. Out of these 988 classified devices, the majority of them, 83%, were actually Mac OS devices, right? And the remaining devices are either iOS or this Red Hat device. So as an end user, I can look at this and say, hey, this looks like a pretty good confidence level that it's a Mac OS. I can go ahead and assign this classification. Now, we do have a way to do auto classification based on this machine learning clustering method that I'm showing you here. But we define specific thresholds to be able to do that auto classification. The first threshold is we want this confidence level to be at least 95%. So if this was over 95%, this would have been auto classified. I wouldn't have to manually assign it here. And the other threshold is we want to make sure we have enough classified devices in this cluster to be able to do the auto classification. So the second threshold is this has to be at least 10 classified devices.
And Mark, I want to quickly point out.
Yep.
Sorry to butt in again, but I failed to mention this during the slides. Yep. But I just want to reiterate that our focus in using AI and ML here, as Mark explained, is really to make things automated as much as possible so that the end user does not have to deal with configuring and trying to process and interact with this ML as much as possible, right? So it's really about simplifying that experience, doing things as much automated. So ML can be used in a bunch of different ways, but our focus here has been to how to let it make decisions for you so that it removes the tedium from having to do it yourself.
Mark, along those lines, while you're on the screen, I kind of want to ask a question, and I'm not poking. I would like to understand this.
No
how would the system? These are the pain points I deal with on a daily basis. So you were kind of showing some nurse call, nurse paging classified endpoints, and now we're kind of looking at a generic endpoint. that had a Mac fingerprint. So, for example, if you have some devices which could be generic in one way, for example, I know a lot of hospitals have nurse paging systems that are actually an iPhone with maybe the SIM card removed and it's wireless only and has some other apps loaded onto it. What's the method for walking through? Because obviously, well, I would say obviously, my expectation would be that's going to require some type of manual intervention. But because you guys have those span and tap ports, how far will the system get you down that? Would it cluster those together and say, here's 30 things that are profiled as a Mac, but they're all kind of going to this same weird server or have this traffic pattern. Therefore, these 30 things or 20 things are similar and classify them together? Or what does that look like?
No, yeah, that's a good question. So the evolution that it would take is similar to what Vishresh's example about the iPad example, right? The more behavioral attributes that we can collect, the better classification that we can do. So given that it's an iPhone medical device, you said, right? But it's running medical specific apps on top of that. And maybe it's connecting to specific, medical destinations from that iPhone, right? From that collection of attributes is how we can be able to differentiate that that's actually a nurse medical paging device versus just a generic iPhone, right? So we can actually do that. It will not have to necessarily be clustered, meaning we can actually do that classification based on directly from the behavioral attributes. That's something that's already that's already an underlying technology within Device Insight that can produce the right classification based on the behavioral attributes. Does that make sense?
Yeah, thanks.
Okay.
Mark, real quick, and I'm going to ask probably a simple question, but if you will bear with me, explain to me just a little bit the DHCP options and how those kind of play in. I want to be certain I understand exactly what you're doing with those.
Okay, yeah. So DHCP options are one of the strong kind of device attributes that we collect for a variety of devices, whether they're user-based devices or so forth. I showed you that one example with a nurse medical device. I can show you like an iPhone specific device, and you'll see these particular DHCP options. So basically, we collect this from the network infrastructure. So these are basically DHCP relay or IP helper that's set up on let's say, your router or switch. And that gets forwarded over to our sensor or our data collector device. And that's how we can actually kind of, add these DHCP attributes for every single device and use that as a way for classification. So, and DHCP options are actually a very strong feature set to use for the clustering of devices. What I showed you in terms of that generic example, the DHCP options were actually strong enough to cluster those particular Mac devices, right? Right here. The commonalities between these 31 generic devices and these classified devices were all based on DHCP options. And these options are basically relayed as, for all the dynamic base IP devices that you have in your network, we're collecting all that DHCP information from those DHCP transactions on the network. That's what we can see from the sensor. So that's how we're able to pull that data.
Okay, thank you.
Does that make sense? Yeah. Okay, so then we go to the next step. And the next step is really how we can get more security context on the devices that we see in the network. And our first pass at doing that is really focused on Windows device. So it's an agentless method, agentless scanning method. In particular, we're running WMI, which is a Windows management instrument scanning method that works on both Windows 8.10 and Windows Server devices. And I'll show you one particular Windows device to show you what type of security context that we see. I'll just search for one of them here. So here's the sample one. Now you see that we've actually calculated a risk score for this particular device. We have a new security tab on our UI, and I can go to that tab, and you'll see there are two things that we do from a security context point of view. The first thing is when we do that agentless scanning method, that WMI scan, we do a vulnerability assessment. So that agentless scan will actually determine the particular OS, patch level, hotfix level, what type of applications are running on this particular Windows device. And we do a cross-check or a mapping against the National Vulnerability Database. And what we can get from that database is the collection of active vulnerabilities, and they're tagged by CVE ID. So common vulnerabilities and exposures. These are the specific CVEs that are active on this particular device. And I can drill down on each of these, and they'll give you a description of what that CVE is, and we even have a handy link to a Microsoft Update catalog page so that you can actually pull the particular patch to patch that vulnerability. So you see that. You'll see that vulnerability assessment contributed 53% of it to this risk score. The second thing that we contribute to the risk score is a posture assessment. And the posture assessment is based on the end user actually will create certain posture rules to check against. So when that agentless scan runs on the device, we'll check against what processes are running, whether or not USB devices are enabled, encryption is enabled on the disk, firewalls enabled or not. In this case, the firewall was set. A healthy device would be considered when the firewall is enabled, and when it's disabled, it would be considered unhealthy. So in this case, we flagged this unhealthy, and that unhealthy posture contributed to the risk score. So this scanning method is done at specific intervals throughout the day, and this risk score will be updated on an hourly basis. And this kind of just shows you the level of security context that we're able to see on the devices. And our first pass, again, is right now on Windows devices. Any question on the security?
Yeah, I've got a quick one. So I guess seeing this, and I know it's the device insight, but how does this differ from like the posture agent and all of that that's built into ClearPass, and kind of is there any correlation between them, or is it a completely separate thing that we're doing? No,
it's actually, yeah, there is correlation between them. So ClearPass Policy Manager has a component called OnGuard that does its level of posture assessment. And OnGuard is actually a more developed functionality on Policy Manager. And we've actually taken a subset of that within Device Insight. So this one within Device Insight works independently of OnGuard. And in fact, if you enable it on Device Insight, it will actually override the information from OnGuard, right? This becomes kind of the source of the posture assessment. But there is some similarity. There is overlap between the two, between Device Insight and OnGuard.
Okay, thanks.
Yeah. Any other questions? I was going to kind of pass off the remaining time to Samuel, who's online, and he'll show you what I talked about here. How do we scale to branch locations, and give an example of how we close the loop with ClearPass Policy Manager. So he'll talk about these two here.
As Vishwesh and Mark were saying, this is my Device Insight account. It is receiving information just directly from my gateway. It is not. I don't have a collector in my lab, and as you can see, it has in some cases through ClearPass, in some cases directly has discovered a bunch of devices. We can pick on one of them, and we can see how this device looks like a Nintendo Switch. It connects to the network like a Nintendo Switch, and it is behaving like a Nintendo Switch, right? It keeps going to Nintendo, Nintendo.net, etc. And yeah, it is a Nintendo Switch. And this information is not just staying here. It's coming to ClearPass. All I had to do was put a token in ClearPass. It connects to Device Insight, and now my ClearPass server has a lot more information. It is receiving these tags that we can create in Device Insight. It is receiving this category, and this category is now the result of a lot more information, not just the DHCP options and the Macro UI and the other checks that ClearPass can do on its own, but also just looking at the traffic patterns and so on. So it's really getting a much better visibility on the network, and that really helps us when we are building a zero trust network where everything has to show its credentials and everything has its unique security policy attached to it. As you can see here in my setup, all my devices are on the same VLAN. I have like a Raspberry Pi, I have a security employee, I have a camera, I have my other computer, which is also a security employee. All these devices are in the same subnet, and I can still apply policy between them. Like that is because I'm applying dynamic segmentation in my network. So as you can see, because I am on the secure user role, and let me see. Because I am on the secure user role, I can see the camera that's pointing to my backyard, and at the same time, I have another device, the Raspberry Pi that you saw that was in the same subnet. This is .143, I am .149, the camera is .140, and this guy cannot hit the camera. And it cannot hit the camera because I have a security policy applied to the employee user role that says, hey, for any user in this role, to any user in the camera role, just deny. Employees are not allowed to look at the content on the cameras. Okay, so we're getting this machine learning to enhance our discovery capabilities or role assignment capabilities, and then we put every device in its container, in its role, and security policy that allows us to enforce very, very granularly the security policies inside my network. And we're not going to stop there. We have enhanced our gateways to also include IES IPS in the 9000 series. And that means that we're not going to just blindly allow my computer to do whatever with that camera. My computer is still being, the traffic between my computer and that camera is still being inspected. So I can look at, this is my computer, I can look at what I've been doing, and you can see here that I was doing some scans that were blocked by the system. If I want to investigate a little more, I can download a packet capture that has been taken in real time. And if I decide that this is an acceptable thing, I can very easily just whitelist this pattern, this signature, and this it would be further allowed. Okay, and that's a relatively harmless type of threat. But the IDS IPS engine is looking at different patterns, the different signatures, and is trying to capture a variety of them. We were seeing a scan before, but we can see other things that are a lot scarier, right? We can see that at one point this other client is doing some possible WannaCry DNS lookup. Well, this is classified by malware as malware. Its severity is critical. So I may not just want to block this traffic. I may want to close the loop and send a notification to my Splunk server, send a notification to send an alert to my ticketing server, or send a message to ClearPass saying quarantine this device. So the idea behind this is that we start by very, very quickly deciding whether we allow the device or not, very accurately identifying the device. We do some posture through the capabilities of Device Insight, or by using the OnGuard agent on the Windows devices, on the Mac devices, basically on the computers. Once you're in the network, we very granularly determine where you are allowed to go based on who you are, not necessarily based on your IP address, not based on what VLAN you are in. And even for that traffic that is allowed, we're constantly inspecting it to catch outliers, to catch things that may look like threats, and obviously close the loop and perhaps revisit that decision to assign the secure user role to this computer that is doing all sorts of strange things.